Welcome to this new video. So you want to learn more about software development, and I am very happy about it. But before getting to the heart of the matter, we will first see how a computer works. Simplified as much as possible, what is a computer? It is a machine that performs operations on data. The part that performs these operations is called the processor. The data can be images, texts, sounds, series of numbers, videos, 3D models, etc. To be processed by the processor, all this data must be stored in what is called memory. Memory can be seen as a long series of small boxes, either full, either empty. A box of this type is called a bit and can represent two values. An empty box is worth 0 or false, a full box is worth 1 or true. With 2 bits, it's possible to obtain the following 4 combinations: 00, 01, 10, and 11. With 3 bits, the 8 displayed combinations are possible. And with the number n of bits, we obtain 2 power n combinations, which will bring us to a small parenthesis to quickly talk about binary. Take for example 10 bits. We will start by numbering them from right to left, starting with 0, then 1, 2, up to 9. The value of each bit then corresponds to 2 to the power of the bit number, so from 2 to the power of 0 to 2 to the power of 9 in our case. 2 to the power of 0 is 1, 2 to the power of 1 is 2, 2 to the power of 2 is 4, etc. For each bit at 1, we will take the value of the corresponding power of 2 and we will add all these values. This 10 bits binary number is therefore 309 in decimal. But let's not go too far with binary, we'll come back to that another time. Back to memory. A group of 8 bits is called a byte. Memory is therefore a long series of bytes, and the processor can access to one of them by indicating its position, which is called an address. Everything is only bytes in memory: sounds, images, texts. The memory therefore doesn't know the type of data stored at such and such an address. It is a program that will decide and indicate that such memory zone contains such type of data. Memory size measurement units are as follows. 1 kilobyte equals 1024 bytes. 1 megabyte equals 1024 kilobytes. 1 gigabyte equals 1024 megabytes. 1 terabyte equals 1024 gigabytes. When developing, it is important to know the orders of magnitude of the data size in memory. Thus, a color can be stored on 4 bytes, one for red, green, blue, and transparency component. An uncompressed 1280 by 720 pixels image, each pixel of which is stored as 4 bytes, will therefore occupy 1280 times 720 times 4. That's about 3.5 megabytes in memory. Now back to software development or programming. The processor only executes a list of orders given to it to process the data at its disposal. Doing software development therefore means using a specific language that will allow the developer to define the orders which must be executed by the computer. This language will be translated into instructions directly understandable by the processor. And guess what? This list of instructions to execute is itself a data that the processor will read in memory. These instructions are stored in memory in machine language or machine code. They are difficult to understand by a human. This is why computer languages such as C, Python, Java, Lisp were created. Because in the end, whatever the language used by the developer, the program is translated into instructions understandable by the processor. The instructions understandable by the processors are quite simple, like read a value from memory, add two values, test if one value is equal to another. Modern processors, like the Intel Core i9, know a few hundred instructions, some of which are just small variations of the same basic instruction. Here we end our quick overview of how a computer works. We've oversimplified things to get the big picture, but a computer is a much more complex machine in reality. consider subscribing and activating the bell. And if you liked this video, consider putting a thumb up. See you soon for a new video.